Hello, everyone. Thank you for joining our session. This is session 4 of panel 3, Innovative Solutions to Climate Complexities. We have a great lineup of speakers for you. I want to thank all of our sponsors, but especially DTE, our host sponsor. And I'll just remind you of a couple of things you may have heard about in other sessions. Please take advantage of the attendee link that is available. And I encourage you to connect with other attendees either through the attendee list or through connecting through the app that we have available. And I also want to remind you that you should take advantage of attending the post-panel debrief after it's this evening for those of us on the East Coast. But I have found those discussions to be very enlightening and an opportunity to engage more with speakers and other attendees. So I would definitely encourage you to take advantage of those. I'll be introducing our first speaker, Carlos Gamarra. He is a senior research scientist in the clean energy technology at the Houston Advanced Research Center, HARC. That is a nonprofit research organization based in the Woodlands, Texas. He has over 15 years experience as an energy engineer, beginning his career as an MEP engineer for industrial and energy infrastructure projects. He developed over 25 industrial energy audits and helped establish 4 ISO 50001 systems from 2011 to 2015. He joined HARC in 2017 and currently leads a multi-year project funded by the Department of Energy to develop a publicly available software tool out of the innovative planning methodology he created for his PhD in community microgrids. Carlos is an electrical engineer, also a licensed PE and CEM, and active in the Association of Energy Engineers Lone Star chapter. So welcome, Carlos.
Thank you very much, Sharon, and thank you for this opportunity to present today. Today I will be presenting on behalf of the HARC team, formed by Gavin Dillingham, Lulu, Margaret Cook, and myself, on a novel decision framework tool we have developed to assess microgrid resilience benefits under different physical climate risk scenarios. So 2020 set a new annual record of billion-dollar disasters in the US. 2020 is the 6th year with more than 10 billion-dollar natural disasters. And as you can see in this, many of them happen in the Gulf Coast area where we are based. So unfortunately, we are very familiar with these kind of disasters and how they disturb our operations and the life of everybody in this area. So we really think resilience is a need, not only for residential or commercial customers, also for industrial customers these days. As you can see in this figure, the US DOE Electric Emergency Incident and Disturbance Report shows a tendency on an increasing trend on the number of power disturbances between 2002 and 2020. So the grid is having issues due to climate risks, to different climate events. As an example, we can say that 181 million outage hours of a total of 19.4 billion hours tracked in 2020 happened in Louisiana. So the Gulf Coast area is an area really prone to natural disasters, as we mentioned before. And why do we want to focus on microgrids? Microgrids have the capabilities to provide resilience in different ways. They can work connected or isolated from the main grid. They can supply energy to these natural disasters prone areas or to remote areas with no electricity supply at all. Also, they can provide power to urban areas, so they're really flexible in that regard. They can incorporate distributed generation, energy storage, clean energy technologies. They minimize transmission and distribution losses, can exploit local fuels or sources of energy, produce electricity with cold or heat at the same time through CHP, cogeneration, and of course they reduce price volatility. And there are other reasons to adopt microgrids, but when it comes to resilience, this is the most relevant ones we would like to point out. What do we want to change? What's the approach? The changes we will suggest through this methodology. So in the present, microgrid planning is typically based on 15-minute interval data at the plant level. Also, the planning process is based on what is called the typical meteorological year, which is the average conditions for the last 25 years. So we are planning microgrids looking back instead of forward when it comes to weather. And typically, the tools in the market use simulation and optimization techniques. While we consider there are several additions that might improve these planning processes, like, for example, the usage of downscale global climate models. There are over 20 climate models, global climate models out there that can be used for these purposes, with the purpose, to have weather trends, to have weather data, weather projections for the next, for example, 50 years, you can use in this planning process. At the same time, there is industrial companies are rich in data. They have been monitoring data for many years now, and many of them have not only energy consumption data at the plant level, but also sub-metering levels, production planning, operational data, maintenance data, and many other data sources. Another thing that might be worth considering when you are planning a microgrid are the historical and real-time CO2 grid emissions. We are in the path of a decarbonization that will inject more clean energy into the grid. So in the future, the environmental emissions from the kilowatt hours we buy from the grid will be lower than now. That's a trend we need to consider if decarbonization is one of the goals of this microgrid planning process, in addition to resilience. Integration with on-site resilience plan is critical, so we want to define how resilient do we want to be and how are we going to accomplish that. It's important to account for the cost of the lack of resilience each user might have, and we really believe that simulation and optimization and risk analysis techniques combined with artificial intelligence can help improve the way microgrids are planned these days. So this is the framework we are suggesting, we are actually promoting through this presentation, if I may say. So it has 4 phases, 8 steps that go from energy efficiency improvements, continues with power demand analysis, local risks, local climate risks identification, the modeling of the impact of climate on the KPIs of the industrial process, the quantification of the cost of resilience, and then we move to the set of resilience goals, the selection of microgrid technologies to finish with the cost-benefit analysis. So let's talk a little bit more in detail about this framework we are suggesting. And then the first step is this is energy efficiency. So at this point, I think most of the industrial companies out there have gone through an energy audit, and many of them have already established their own energy management system or have adopted an energy management system based on one of these international or national standards. So when it comes to decarbonization, energy efficiency is a must. But energy efficiency is also a must when it comes to streamlining electricity demand for industrial processes, because it allows you to plan for, so your resilience requirements are lower when you are efficient than when you are not. So that's why we think this is the first step in the process to reduce, and these energy efficiency improvements will help you reduce the load the microgrid might need to manage during a contingency. Next step will be to analyze the power demand. So typically, when a microgrid planner looks at the 15-minute interval power demand, he or she looks at the maximum, the minimum, and some other aspects of the power demand curve, at the power curve. But there is a lot of data that can be leveraged on this analysis that comes straight from the industrial process. And the machine learning and artificial intelligence techniques can easily integrate, like the main meters have metering data, production and maintenance data, starting and stopping procedures and loads. And of course, the energy audit is a really good source of information when it comes to identifying how much energy is consumed in in any system, in every system of the industrial side. It's important also to highlight that a microgrid must be designed for its highest efficiency during the most frequent power demand scenarios. We want the microgrid to be cost effective, besides providing the resilience we want. So, for example, we are showing a couple of figures here. The figure in the left is showing the power demand, the 1 hour interval power demand of a distribution center for a potato snack factory. So basically, you can identify here the status of the process just looking at to the curve. Sorry, we can see production time, we can see vacation time, we can see maintenance time. But more importantly, we can also identify that most of the time, 70% of the time, the consumption of this process goes moves in the range of 200 to 300 kilowatts. So that's the power capacity range in which we want the microgrid to be optimized, to be more efficient, although we also want the microgrid to provide resilience for any other status we might consider for this industrial process. Okay, once we have analyzed the power demand, we will focus on analyzing the climate risks associated with we are in. So each location is prone to different climate risks. It's important to establish historical climate patterns in the area and which type of natural disasters have affected the area in the past. But it's also important to consider climate projections to assess the likelihood and frequency of future events. And that's where downscale climate models came up. As I said, sorry, I probably didn't mention this before. So downscale climate models are basically, we typically take these global climate models and downscale them to a region, so we can make these weather forecasts for the weather projections and identify weather patterns for a specific area. Why is important to consider them? Because, for example, since 2000, overall flood damages have quadrupled in the US. So if we look at historic data, we wouldn't see this fact. A record of 30 named storms formed in the 2020 hurricane season. 14 of them became hurricanes. And of course, here in Texas, we all remember the winter storm Uri because it left millions of people without power for days. So it's important to look back, but also to look forward. And climate models, downscale climate models are perfect for that. When you look at risks, there are mainly two types of risks, long duration risks or short duration risks. Which risks should an industrial company look for is up to the company, but in general, industrial companies tend to usually look at short duration risks like power blackouts or flooding damages, while we consider it's also interesting for them to look at an increase in the ambient temperature that might affect the performance of part of the industrial process or the on-site energy generation performance, or even, I don't know, the availability of water for the cooling systems the industrial site uses. So there are different reasons to consider not only short duration risks, but also long duration risks. And how do we do that? So in step 4, in step 4, we recommend to integrate the climate models into what these days we call a digital twin manufacturing process. So manufacturing companies have always been modeling their process with different equations in different ways when it comes to quality, when it comes to production, different inputs, outputs, right? So it's important for us to incorporate climate variables in these processes. So that way we can model the impact of an temperature increase on the performance of the manufacturing process, or we can see how that affects the energy consumption of the site. It's also important to quantify the cost of the lack of resilience. So each industrial company is almost unique. Doesn't represent, so every company has different dynamics and different risks based on its location, but also every company wants to behave differently. So for example, there are some examples in this. For example, a flood leading to a power blackout could last up to days, and a company might decide to shelter in place and continue operating, which might translate into additional work hours and additional cost of $4,000 per hour. While when they are dealing with a heat wave which might last up to weeks, they might decide to continue business as usual and just paying the additional energy costs, which might be $8 per hour. But when cold wave leading to a sudden, when they suffer a cold wave leading to a sudden power blackout, which might last up to days, their process might be shut down suddenly and need to make calibrations or repairs before restarting the production chain. So it might cost them $10,000 per hour. It's important to assess these costs and to incorporate them into the cost-benefit analysis. And it's also really, really important, and this is the core of these methodologies, to set the resilience goals. So specific plants have specific resilience goals. Even the same manufacturing process in different locations might have different goals when it comes to deciding what to do when there is a natural disaster affecting them, right? So different factors that influence the resilience levels required might be like the severe type of severe weather, if it's a multi-day event versus a single-day event, the nature of the services the factory or the industrial company is providing. An example is like, for example, greenhouses require high levels of resilience, right? Losing power for them, they might lose the production. But for example, plants producing non-perishable products might decide to close the factory for some days and catch up in the following weeks with additional workloads or work hours. So it's up to every company to decide how to deal with these situations, how to plan for these situations. Also, the nature of the industrial process can help or not. Frozen food factories can stand brief power outages with minimal losses. They have this thermal inertia in their facilities that, I mean, a 10 minutes power blackout doesn't bother them too much. And 1 hour, even a 2-hour power blackout might not be a huge loss for them. Wineries or breweries that mix these manufacturing process, so to speak, this bottling process with cooling or heating needs that might be more affected, but the nature of the industrial process is also important. So in the end, a simulation of the demand profile based on the forecast production, energy consumption data, the downscale climate data used to forecast also the energy consumption, how it will look like, and resilience goal might, and it's interesting to assess the resilience goals and how it's interesting for the microgrid to be properly sized, because it's not the load you have today. You will be planning the microgrid with the load you will be most likely having in the future. So at this point, when you know all this data, you know how your loads might change in the future, you might decide, okay, how do I define my contingency plan? So do I want to use on-site generation to back up the entire process, part of the process, or do I use contingency power to aid the transition to a standby or a secure mode? So different strategies you can follow when a natural disaster hits your site. So do we stand by? Do we keep on continue working? Do we just, different goals. Resilience goals are usually stated in kilowatts to be back up during X hours, and microgrids can implement different strategies without interrupting the power supply. But those microgrids are more expensive typically than those able to stop and restart in a few minutes. When you know your needs, when you have a resilience plan, you need to look at the technologies that are going to be able to give you that resilience based on the natural disaster we are facing. And for that, the Department of Energy has this interesting matrix that shows you how likely are these technologies to be impacted by different natural disasters. Of course, this is one resource you can use, but this is something to take into consideration. And in the end, the last stage is the cost-benefit analysis. So what we are suggesting, as it was mentioned during our presentation, we are working on developing a project developing software tools and using computational optimization algorithms to explore multiple technologies combinations in an agile way. So there are many softwares out there, but most of them are simulation softwares, which analyze one solution at a time. We recommend using a software that can speed up that process. Look at the feasibility level for multiple options, analyze them quickly, and let you know which solutions are most likely to fulfill your goals. After going through a feasibility analysis, still we recommend to check different aspects of the solution. Like, for example, minimum and maximum power generation limits per generator, sorry. So a person can think that the 1 megawatt generator can produce any amount of power from 0 to 1,000 kilowatts. But depending on the technology, it might be the case that generator only can go down to 300 kilowatts. And you have to plan for the smaller range, from 0 to 300 kilowatts. Generators also have ramp up and ramp down capabilities, and up and down times we need to consider, because you may want to start the generator, but it takes time sometimes for some technologies to start and be able to deliver 100% of the load they can provide. Also, when we look at energy or thermal storage, we need it to be cost effective. So we need to look for the usage factor. So we need to make sure that storage capacity is also used during regular operations, not only for contingency operations, or at least part of it. And another thing to look at is the number of annual starts and stops required at the facility. And just to finish this presentation, mention that microgrid controls have not been fully standardized yet, resulting in different solutions. But in the end, we just need to, vendors are able to provide very valid solutions these days. And the analysis finishes just with accounting for the cost and the benefits of having the resilience, and comparing the non-resilience scenario with a resilient microgrid scenario, and calculating which would be your savings in typically net present value or investment internal rate of return. Sorry. Yeah, and this is my presentation. Thank you very much.
Thank you, Carlos. Our next presentation has two presenters. I'd like to introduce them. Amy Papalorum is a Senior Program Manager with Channel's ComEd Energy Efficiency Business Programs. In that role, Amy manages C&I outreach and coordinates with internal outreach and engineering functions to ensure that customers receive maximum value from ConEd's Energy Efficiency Program. She holds a BS in journalism from Ohio University and an MBA in marketing management from DePaul University. Joining her will be Andrea McKenna from Cascade Energy. She is the program manager for ComEd Industrial Outreach at Cascade Energy. She's an engineer with over 15 years of project management and consulting experience across many industries, including energy efficiency, forensic engineering, and software. She earned her MS in mechanical engineering from Northwestern University and a BA in science, I believe, from the University of Toronto. So welcome to Amy and Andrea.
Good afternoon. It's nice to be here. Thanks so much for having us. As Sharon said, you have my background, so I won't go into that too much more, other than that I am the program manager in charge of outreach for commercial and industrial outreach for the ComEd Energy Efficiency Program. And with me today is Andrea. And we did want to give one other shout out to Joe Mays from Resource Innovations as one of the contributors to our article. So thank you, Joe. Next slide, please. Thank you. So our outreach team is made up of several different groups, and we work together and we complement each other's skill sets to get our outreach, and maximize participation with those customers in our territory. So in terms of the account managers are responsible for managed accounts. They work with all the day-to-day issues. So they work energy management action plans into what they do with customers day to day. We also have outreach service providers. So there are external vendor network, and they're segment based. So in the case of Cascade Energy and Resource Innovations, they're our industrial outreach team. We also have ComEd engineers who are involved in many different phases of the selling, the selling process, if you will. And then various energy efficiency contractors, both contractors who just come into the network on a project basis, and also energy efficiency service providers who are more vetted and embedded more in our program. Next slide, please. So our goal with outreach, not unlike the previous slide, is to offer end-to-end support. So what we're trying to do is, if we have newer customers, we're working on education and awareness. As they become engaged in the program, we're helping them navigate where to get their incentives and maximize participation, and then also get them to re-engage later on future projects. And that's really important in industrial in particular. So with that, when we hit, a very sudden shutdown over a weekend in mid-March last year, it really, slowed down our progress in being able to maintain this very fluid participation and processes. And that, none of this is new to outreach, but with the shutdown, it really, caused an abrupt stop and caused us to look at our tools and processes, the programs, offerings themselves, other things in our process, just to see what we could do for customers to keep the momentum going, since everything stopped pretty abruptly. Next slide. Thank you. So the issues that our customers in the industrial and other segments have faced were exacerbated during COVID. So illnesses, personal shortages, changes in capacity, operations, supply chain. I've been in attended at least one presentation earlier in the week that mentioned several of these. So they definitely are lingering issues, and they were just exacerbated at a time where we couldn't even get into the facilities to help the customers. So we worked to, another issue with this was that we were trying to, help the industrial segment, and Resource Innovations and Cascade had only been in their role about 6 months when all of this came. So just about the time where you're starting to get some momentum, you've got some awareness with customers, they understand, who you are, why you're there, that you're building some trust, and then the COVID time hit. So we looked at different programs, processes, and can you go to the next slide, please? So, what we did is we just looked at different things in our, we knew that what customers care about were also issues that we could tie or ladder the energy efficiency benefits to in many cases. So we looked to do that wherever we could. And that helped us, keep a focus and momentum on energy efficiency. Next slide, please. So getting a little more specific, just like any other energy efficiency program likely does, each year we look at what worked, what we could do more of, what we could shift into another area, those types of things. So we had already made some changes in early 2020 to make our program easier to participate in, take away points of friction, things like that as best we can. So we had offered online applications, or we had an online application out there. And as soon as COVID hit, that became more of a lifeline and more of a gateway for the program, if you will, because all of the in-person activity and papers and application filing and things like that, it became very important to keep the momentum going with customers. We also had increased the number of measures and lowered the ceiling on needing to do a pre-application or a reservation for incentive funds for projects. So there were a lot more projects that were able to go straight to a final application. We also had expanded the measures and offerings available in our instant discount program. And what that entails is working directly with a lighting distributor, for example. And we have expanded into some HVAC measures as well. So again, that was another way for customers to continue participating, even though they were in, reduced capacity and we couldn't get into facilities. And then finally, the incentives for operational measures, we were unable to get into facilities, but in many cases, the customers were still there, and we were able to target operational measures that were either no cost or very low cost, and behavioral changes that were able to help them save money right on the spot. So those were things that we did there. Excuse me. So moving on to some of the tools we used quickly, we knew instantly that obviously you can't do a walkthrough in a facility if you can't get into it. So we looked at ways we could create a virtual version of our facility assessment, and that typically involved an engineer working closely with customers, either via phone or via teleconference, to do certain assessments of the building and then providing the report after. We found customers really enjoyed. We had customers who really liked the efficiency of that, and we also leveraged tools such as our Business Energy Analyzer tool, and that actually Andrea will show you a screenshot of shortly. But it's a way to analyze interval data to see if there are anomalies in how energy usage is taking place in a facility, to see if there are leaky bucket opportunities to correct. So we did a lot of things like that. We also leveraged segment-specific webinars, and I won't touch on this too heavily because I think we all know intimately, how we've leveraged videos and teleconferencing in the last year or so. But we typically focused on an audience type and or an equipment or a measure set that would be of interest. And what we found there is it was a good credibility builder, particularly when you're still bringing in new customers. It also provides a level of confidence that other customers are taking, advantage of the program through case studies and other examples. So that was effective. And then finally, remote meetings, we really just pulled out the stops on all of the best practices. Again, I won't belabor that since we've all been doing that, but, really doing our homework, doing whatever we could in the absence of being able to be in the facility itself, doing facility profiles, pulling up, data, making, some data assumptions to keep it easy for the customer to engage in a conversation and getting them engaged in calls. The other advantage we found was that with customers and, our network of outreach folks not having to travel so much, there were greater opportunities to bring teams together. So maybe an LCS manager, an account manager, and a outreach person went to a meeting. Well, now we might be able to also have a ComEd engineer involved in that call, and or some bench strength from the outreach service provider who might be an SME on a particular topic or measure equipment, that sort of thing. So all of those things worked in our favor. And, those were things we just leveraged. It really helped with relationship building. I would say from my perspective, it helped buoy the momentum that the industrial OSP had. And we had the same thing going on in numerous other segments as well. So that's a high level of, some of the outreach behaviors that we, implemented during the pandemic. I'm going to turn it over to Andrea now, who's going to get into a little bit more detail about some of the successful metrics and measures and, tactics that they used, as well as a few case studies. Thank you.
Thank you, Amy. So during the pandemic, we found that energy efficiency measures that take little to no capital to complete were particularly appealing to customers. And I'm going to call them low and no cost gems here. But we identified these through new or previous facility assessments or compressed air leak surveys. As Amy has alluded to, ComEd has some online tools for customers, including the Business Energy Analyzer, and there's some images from that tool here. You can see there's a heat map, which really helps to visualize energy use and identify days and times where the energy use might be unexpectedly high. So that was a great way for outreach engineers to spark discussions with customers to figure out why that might be or what potential solutions we could implement. Here on the slide are just some categories of low and no cost EE measures that we looked at. So for example, shutting down equipment. That could be turning off lighting in unoccupied areas or shutting down idle process equipment. We had set point scheduling and optimization, such as thermostat scheduling in office areas or chilled water temperature resets for chillers. Equipment sequencing, and that might be optimizing the sequencing of air compressors or condenser pump and fan sequencing for central refrigeration systems. And then finally, leak repairs, whether that's in compressed air systems or vacuum systems. One of the most popular ComEd EE programs is the Compressed Air Fix It Now program. And that's one where service providers are paid directly to identify and repair leaks at the customer site. So essentially, the customer can begin saving energy immediately with no upfront cost. And then finally, I would throw in maintenance and repairs also into this low and no cost category. So for example, making sure that filter screens are clean and repairing failed sensors. So after an initial focus on low and no cost projects, that really opened the door to larger capital opportunities at different sites. And energy management programs are great for this. SEM, for example, involves recruiting a cohort of segment peers, holding technical workshops, and conducting site-specific facility audits to look at energy efficiency opportunities across all the major energy systems. Outreach engineers first identified and then reached out to customers who would most benefit from energy management programs. And those are typically mid-sized to large customers looking to develop their own internal energy efficiency team who display motivation and have staff availability as well as support from their leadership or corporate level. Ongoing coaching kept customers motivated by breaking down a variety of EE projects into manageable pieces with monthly goals. And finally, an online performance tracking platform helped customers to visualize their achievements. Industrial systems studies are a study-based option for customers who really want to hone in on a single energy system at their site. So that could be compressed air, process cooling, or industrial refrigeration, for example. And a great benefit of these studies is that the same service provider can investigate the EE opportunities and then implement the capital upgrades. And then incentives for any O&M measures can help to offset the cost of the capital upgrades. So I've just mentioned a variety of ComEd EE programs. This continuum here is just one way to visualize how the different programs can meet customers' desired level of involvement in their EE journey. And it also shows a program's general focus, whether it's operational and maintenance focused or more investment and capital project focused. So on the far left, we have things like compressed air leak fixes that require less time commitment on the customer's part versus something like strategic energy management that looks at all the major energy systems at a plant and asks for staff participation over a year or more. So those programs towards the top left of this screen are those that were particularly appealing to customers in 2020. And so we saw compressed air leak surveys and facility assessments as being great gateways into other programs, as they were low stakes way for customers to start dipping their toes into energy efficiency. So to wrap up, I just want to share a few case studies that show how we leveraged the different programs to help several customers achieve significant savings last year despite the pandemic. So for each customer, you'll see a table that lists the different projects in the first column that were tackled in 2020. Then we've got the annual energy saved, estimated dollar amount savings in the third column, which is based on the average retail price according to state of Illinois data. And then finally, the incentives paid out by the EE program. So as the pandemic was ramping up last year, we worked with a plastics manufacturer who wanted to renovate some existing unused space at their facility and expand their process cooling and compressed air system in order to manufacture ventilator parts. So as you can imagine, we were working on a quick timeline. The outreach engineer assisted with the energy efficiency program participation, working directly with the lighting vendor to ensure that the lighting project qualified for and would receive the maximum available incentives. And that really enabled the customer to focus on their expansion and their production. So the outreach engineer on our team acted as a main point of contact, setting up meetings with all involved parties. And of course, the ComEd account manager was involved throughout the entire process. So looking across the bottom row of this table, you can see that this customer saved over 276,000 annual kilowatt hours last year, and this represented about 8% of their 2020 energy use. We also worked with ITW Deltar, and they are an auto parts manufacturer in Frankfort, Illinois. And they did 2 facility assessments prior to the pandemic, but they didn't implement any of the recommended EE measures at that time. So in early April of 2020, our outreach engineer re-engaged with the customer and helped them with their first compressed air leak survey. This led to ITW acting on the recommendations from their more recent facility assessment. And then they moved on to larger capital projects, as well as participating in an energy management program. And I just want to highlight a couple of the projects that ITW tackled last year. The first is a process efficiency industrial study that focused on adding blankets around their injection molding machine barrels. In this case, the incentives substantially offset the cost of the project. They also centralized their resin drying system. And so they replaced individual resin dryers at the injection molding machines with a smaller number of central high efficiency dryers. So this not only reduced the total overall heating and blowing power required, but it also improved ITW space utilization. So in 2020, the Deltar site saved over 2.1 gigawatt hours of energy. And the success at this site opened up conversations with ITW's regional manager. And since then, we've plugged in 2 additional ITW sites into the ComEd programs. And finally, we worked with a packaging and dispensing manufacturer with 2 sites in Illinois. They started with compressed air leak surveys and strategic energy management prior to the pandemic. But engagement with the outreach engineer and the ComEd team kept the customer motivated throughout the pandemic. And now both sites are taking full advantage of the wide variety of ComEd programs. They even have a vacuum process efficiency study going on this year. In 2020, each of the 2 sites saved about 5 to 6% of their annual energy use. So just to summarize, the pandemic made 2020 a challenging year, but ComEd account managers, energy engineers, and outreach service providers all really played an integral role as part of a team that kept customers motivated to implement EE projects. And so with that, on behalf of ComEd, Cascade Energy, and Resource Innovations, I want to thank you all for attending our presentation today. Thank you.
Thank you, Amy and Andrea. I appreciate that very interesting presentation. Last, we have Danny McRae, and I've known Danny for a long time through the Energy Star Partnership, so I'm happy to welcome him to this session. He's an industrial sector manager with the U.S. EPA's Energy Star program. Energy Star is a voluntary government program that works with manufacturers to increase energy efficiency and save money on electricity and fuels across their operations. Danny leads initiatives with several manufacturing sectors to identify best energy management practices and create benchmarking tools to improve sustainability through improved energy performance. Prior to EPA, Danny managed environmental and agricultural projects for USAID and a municipal benchmarking initiative for the Connecticut Green Bank. Danny is a certified energy manager and holds a master's in environmental management. So welcome to Danny.
Thank you very much, Sharon, for the introduction. Good afternoon, everyone. As Sharon mentioned, I'm Danny McRae, and I am with EPA's Energy Star program. So the theme for this session is innovative solutions to climate complexities. And there are different solutions to address greenhouse gas reductions, but there are also different categories of solutions. So sometimes the first thing that may come to mind are technologies that could be installed to reduce greenhouse gas emissions. But we know beyond that, there are policy solutions. We've heard a lot over the last few days that strategic energy management could be one approach to help reduce emissions. What I want to do is offer a fourth category of approaches to help reduce greenhouse gas emissions, and that's benchmarking. So benchmarking is really just comparing your organization's energy or carbon reduction performance and practices to others. So companies can benchmark not just their progress to reduce greenhouse gases, but they could also benchmark how they go about doing it. So benchmarking doesn't really create anything new, but it's a way for companies to learn what their peers are doing, and it could help benchmark whether they are as efficient as they perceive themselves to be. So that's going to be the focus of my presentation. So I'm going to share the results of an activity where companies benchmarked how they implemented their energy management programs, specifically how they implemented the Energy Star guidelines for energy management. And if you're a manufacturer on this call, when I go through some of the results, this should help give you an idea of maybe how some of your energy management practices compare to others. But more broadly, I want to offer this to say that benchmarking can and should be applied to carbon management for disseminating innovative solutions. But before I get into the results, just want to give a little context to the guidelines. So the guideline for energy management was developed by EPA in the early 2000s, and it's a set of principles on how to set up an energy management program. The guidelines were developed based on best practices from leading companies. And the common denominator between all those companies is that they were implementing some of these characteristics that are in this diagram below. So a lot of these companies weren't just doing energy projects, but they had a policy where they committed to energy management. They had goals, they had action plans, they had ways to implement action plans, and they constantly reassess. So the guidelines for energy management have also helped inform other programs, from utility and program administrator-led strategic energy management programs to the creation of ISO 50001. And they've also been used to help inform management for other media, such as water. And there's no reason why they can't be used for carbon management as well. So the guidelines, Energy Star also has an energy management assessment matrix, which complements the guidelines. And this helps programs understand how their programs stack up to the guidelines. So for example, the guidelines will encourage companies to make a commitment to energy management, and it goes through how they could do that by making sure that you have someone who's in charge of the program, making sure that you have staff who are implementing it, and making sure you have a policy. All right, sorry. So again, the guidance are really providing a framework of broad actions of how to structure a program. But one thing that you find is that companies may be following the guidelines, but they are implementing them differently. For example, the guidelines will encourage companies to establish goals, but companies will have different goals. The guidelines encourage companies to track energy, but we see that companies are tracking energy at different levels. So to find out how companies were implementing the guidelines and whether there were certain best practices for these, we conducted a questionnaire and a benchmarking activity with our Energy Star industrial partners to see how they were implementing these. All right, so the goal of this study was, again, to see how companies are implementing the guidelines, with the hopes that participants would be able to see whether their companies were leaders or whether they could learn more from others. We conducted this activity in the summer of 2020, and we had 42 manufacturing companies participate, which I think kind of represents a good cross-section of the manufacturing sector. So we had companies from heavy industry, chemicals and refining, glass, paper, and cement participate. But we also had companies from lighter and medium-sized industry, from motor vehicle sector, pharmaceutical sector, food sector, and so on. And the companies that participated in this activity, they each received a customized report that showed how their company compares to others for each of the 40 questions that were asked. So this shows a page for an illustrative Energy Star partner. So for example, one of the questions was, what is the payback period for an energy investment project? And what we could see from this chart over here is that most respondents, the average response was that the payback period would need to be about 3 years. In this case, the company that said this, they did 4 years. So this is able to give them an idea that they are maybe a little bit ahead of the curve, doing a little bit more for energy than some of the other companies. And I would say one of the values of this report is it's not just talking about the results, but it's actually showing companies where they stand to others. So if you're to the right of the line, it shows that you're a leader. If you're to the left, it means maybe you could learn more from what others are doing. So what I'd like to do now is I'd like to go through some of the results, some of the other results of this activity. And this may look familiar. This is the guide. This is the diagram for the guidelines for energy management. So I'll just pull out a few key questions on different aspects for this. So the first part of guidelines, as I mentioned, is to make a commitment to energy management. How well a company manages and governs energy will really impact how successful they will be in making efficiencies and reducing their carbon over time. And as I mentioned earlier, there are a few ways to do that, but one of the most important ways is really to have someone who's going to lead the program, someone who's able to have some influence over the program. So we asked one question that was related to how the program is governed. Specifically, we asked companies to indicate how much influence their energy program has over different parts of their company that either use energy or have an impact in how energy decisions are being made. This graph over here, if we start with facility energy use, if we just look at this line, this is saying that around 51% of the companies that participated said that they have a lot of influence over facility energy use in their organization. And it also shows that probably about 40% or so self-reported that they have some influence. This is no surprise because, again, this questionnaire was given to Energy Star partners, companies that have committed to energy management. But what I think is interesting, if we look at some of these other areas of the organization, if we go to process energy use, we know that the actual processes can consume a lot of energy, especially in manufacturing plants. And overall, we saw that it was most common for programs to indicate that they have some influence in that area, maybe not a lot. So this means that if that company has a lot of influence, they're a leader. But if they have some influence, they're kind of in the middle of the pack. So another question that we asked with regards to making a commitment to energy management is how many human resources were devoted to this. So one part of the guidelines encourages companies to create energy teams, people who are actually going to implement the policies and manage energy. So the question that we asked was, how many FTEs, how many full-time equivalent staff are in your energy program? And this graph over here shows a distribution of responses. So if we look at how many FTE staff are working on energy in headquarters, we see that that the median is between 2 and 3 staff, this light gray over here. And you could say that a little over half of them would have at least 2 or so staff. If we look at how many FTEs are in larger plants, we see that decreases a little bit where the median is between 1 and 2 staff. So if your energy program is trying to think how you could get more resources, human resources, to help with energy management, seeing how many resources other companies have could help you. All right, if we go to the next part of the guidelines, assessing performance, this is basically saying that you can't track what you don't measure. Current and past use will inform energy savings opportunities. So after you make the commitment, you need to really assess how you've been doing, which will help identify areas for improvement. There are a lot of ways to do that, but the one question I want to highlight here is has to do with metering. One of the questions that we asked companies that participated was, what is the most granular level of metering in your larger manufacturing plants? And this graph over here shows the most granular level of metering for different energy sources, electricity, natural gas, steam, and so on. And what we find is the norm is in larger manufacturing plants, companies are going to have some degree of sub-metering. Norm is generally for it to be at the department or substation level. For natural gas and for other utilities, many times you're just going to find the utility meter at the site or the building level. So one of the takeaways for this is, I hear in discussions with Energy Star partners, how can we justify sub-meters? Probably have a whole webinar on that, but one thing I would say is if you look at this over here and you're looking at sub-metering for electricity, you could point to, for companies that have made a commitment to energy, it is the norm for them to have some degree of metering in their larger manufacturing plants. All right, the next part of the guidelines is about setting goals. So setting goals aren't just great for showing a company's commitment to energy. Goals are really going to help companies stay on track, and it's going to motivate staff knowing that they're working towards something. So there are a few questions that we asked regarding goals. The guidelines says the first thing to do is to determine the scope of the goals. So one of the questions that we was, what kinds of sustainability goals the company have at the corporate level? And the choices were, do you have energy goals, greenhouse gas goals, water, and so on. This chart over here shows whether or not the companies have goals. And if they do, it's broken down to show how that goal is reported, whether it's an intensity-based goal at the corporate level or an absolute goal. So if we look at energy, we find that over 75% of the companies, probably closer to 80, are going to have an energy goal. And over 80% will also have a greenhouse gas reduction goal. Again, not surprising given the population that this survey was sent to. But what I find most interesting is when we look at the sample level data, 2/3 of companies have both an energy goal and a greenhouse gas goal at the corporate level. And that makes sense because sometimes they measure different things. Energy efficiency in many cases will lead to greenhouse gas reductions, but sometimes greenhouse gas reductions, if you're purchasing electricity through a PPA, that doesn't necessarily lead to efficiency. But most companies found that it was important to have two separate goals for that. And then similarly, we found that a little less than half of the companies had an energy goal, a greenhouse gas, and a renewable energy goal. So the next thing we were wondering is, well, what exactly are those goals? Companies are going to set their goals for different time periods. So one company may have a 10% reduction in 5 years. Another one would have 20% reduction in 10 years. In order to normalize that, we took the actual goal reduction and divided by the number of years to figure out what that average annual goal increase or decrease would be. And what we found here is, by far, for the companies that had renewable energy goals were by far the most ambitious compared to the other ones. we found that of the companies that had renewable energy goals, most of them had a goal that would look to increase renewables by 3% or greater per year. And when we look at greenhouse gas reductions, we found both greenhouse gas reductions and energy. We found that it was most common to have between a 2 and 3% reduction. So if you are a manufacturer on this call right now, what I would ask you to do is think about what your company's goals are, normalize it per year. So what's your average goal per year, and see where you fall on here. If you're to the right of this line, it shows that you could be a leader among companies that have committed to energy. But if it's to the left of the line, maybe it means next time you are resetting your goals to try to understand a little bit more about what other companies that have more ambitious goals are doing. All right, if we go to the next part, create an action plan. So a company may have great goals, but how are they going to implement it? The guidelines recommends determining roles and resources. And when we talk about resources, sometimes a lot of times it has to do with what kind of budget does a company have for energy management. So some companies are going to spend a lot on energy, others are going to spend little. What we asked is approximately how much do companies invest on energy projects divided by your total energy costs. So if a company invests $30,000 on energy project and they spend $1 million on energy, they would be 3%. So this over here is showing that on average, companies would invest about 3% of the amount of money they spend on energy back into energy-related projects. So this will give you an idea of generally how much companies are spending on energy. And then the last question I'm going to go through is talking about how companies are implementing their action plan. A company could have a great action plan, but unless management supports it, unless the managers at the plant level are excited and supportive of it, it may not go very far. It really requires mobilizing staff and getting them excited and making sure that they're committed. So one way to do that is building capacity of staff. And one question that we did ask is companies have annual or semi-annual energy or sustainability summits. We've seen a lot of Energy Star partners having them, but we were curious generally how many do. And it turns out that of the companies that participated, 50% have these annual or semi-annual energy and sustainability summits. This is an opportunity to get people involved in energy management, let plants from across the company share best practices. And what we find is we asked who is invited to these summits. It's not surprising that folks from sustainability teams and facilities and process engineers came, but some companies would even invite their C-suite, legal departments, and other support departments. It's also common for some companies to invite folks from the outside, most commonly suppliers or service providers. But we also found that some companies over here would invite peers in the same business or in different industries to learn from. All right, so that concludes what I would like to share. What I showed here were just a few questions from the activity that we conducted. I want to reiterate that benchmarking is a key component in continuous improvement. So I showed how Energy Star partners who have committed to the guidelines may have implemented the guidelines, but show that there was a lot of variation in how they did so. But through benchmarking, they could see where they stand and they could get ideas of how they can improve their programs. And while the guidelines have been developed for energy, they can certainly be used for carbon management for these reasons above. Thank you very much.
Thank you, Danny. So we have several minutes here for question and answer, and I'd like to invite all the speakers to come back on screen with me. We'll wait just a moment. All right, good to see you all. Okay, so I'll start the questioning, and I would encourage our listeners to continue posting questions in the comments if they would. But I'm going to start out with a couple of questions related to the pandemic, because that is certainly something that is top of mind for everyone, I think. So Amy and Andrea, and I'll let whoever is appropriate to answer this question, but one thing I've learned is that as much as we all hated the pandemic, there have been some positive things that have come out of the pandemic. And so I just wondered, since you found ways to sort of pivot and be successful within the pandemic, do you have any learnings from participating in different ways that you want to continue into the future that you found to be beneficial?
Sure, I'll go quickly, Andrea. I'm sure you have some too, but I think we're definitely going to continue to offer a virtual facility assessment type of offering. I think we also learned a lot of good lessons about working together. We have a lot of account managers, a lot of outreach people, program outreach, engineers. So it is a big ecosystem that expanded greatly in 2018. And I think the remote and pandemic situation really helped us collaborate better, because it crystallized the goals we had for customers and ways that we could, again, complement each other's skills. Andrea, what else might you suggest?
Yeah, kind of building on what Amy said. I mean, I think having to do remote meetings and things really normalized that for a lot of folks who may not have been as comfortable, sitting in front of their computer to meet before. But, now it's really enabled folks to invite additional members of their team to calls and have a really collaborative discussion. So we might be able we could talk with some plant staff, but also invite, corporate or leadership members who might be based in a different city, to get everyone on the same page. So I think that I'm hopeful that will continue. But I think that everyone has gotten used to it. And so that is one positive that has come out from the pandemic.
Okay, thank you. And Danny, let me ask you, in interacting with Energy Star partners, and I am an Energy Star partner, but many of us found that we had to work differently. So I'm just wondering, are you hearing anything from the Energy Star industrial partners about how COVID affected them in terms of their being efficient or effective with energy management?
Yeah, definitely. I mean, during the beginning of the pandemic, and certainly during the pandemic, this was one of the topics that we were seeking feedback from our partners about, not just how it was affecting them, but also have you thought of any unique ways to continue your role while you may be working remotely. And I think the folks from ComEd and Cascade mentioned a lot of the things that we found. But I would say that, I mean, it is interesting. It seems like it has affected sectors differently. So some sectors, the production decreased, so the efficiency went down. For others, it was the opposite. But even within sectors, within the food industry, for example, it could really be on a plant-by-plant basis. It had to do with sort of how their supply chains were organized and whether stuff was going to commercial end or to the retail end. So it really varied.
Okay. Yeah, Amy, did you want to add something?
Yeah, just to build on that, we have other segments. So if you think about healthcare, our healthcare outreach service provider, what kind of a, pickle they were in. However, our lead there has been in the industry, for eight years or so. So he had really, really long-standing relationships. So even though there was absolutely no way he was getting into a facility, not only because of the pandemic, but because of our restrictions and safety guidelines, he still was able to work his business. Another example is K through 12 schools. What we found quickly is that, hey, there are no kids in here. Let's get these projects going. And so we were able to do a lot of work that, was kind of unanticipated. So to your point, Danny, it really did vary by industry.
Interesting. Okay, let me turn to Carlos. We have a question from our audience. What climate risk models do companies often use to evaluate risks to their sites? And that's actually related to something I was wondering about too, because I've certainly heard of climate models, but I was not really familiar with the downscaled climate models. So if you could address that a bit more.
Sure. So there are different, global climate models is a wide concept. So not although each model deals with different parameters. Like for example, some models deal with air temperature. Some models deal with water availability. Some models deal with different climate parameters. So not every climate model addresses all the parameters or the climate variables you will consider for this study. So we work with two, one called Mozart and one called GCAM, but there are many others out there. I mean, every company works with different global climate models.
So if a company was interested in using a climate model, how would you get one?
Typically, those climate models are publicly available. It's true also that it takes time to learn how to run them and how to analyze the results. But most of them, some of them have been developed by national labs and other public funded entities, so they are available on their websites or on public repositories. But as I said, it's also true that it takes some knowledge and some time to run these models and to downscale the data. But yeah, they are publicly available.
Interesting. Okay, Danny, we have another question from the audience. We're wondering if the questionnaire includes questions on how corporate headquarters put their energy, greenhouse gas goals into actionable plans for their facilities. If so, what are the findings with that?
Yeah, that's a great question, and I probably want to go back to the full report to find specific questions. But what I can tell you is there were some other questions that asked about plant-specific metrics. So whether the goals were set by headquarters, whether they're plant-driven, or whether it was a combination of both. We asked questions about how companies would set the goals, what factors came into that. And then also there were some questions about the primary criteria for selecting energy projects. I think it was most common for energy projects to be selected based on simple payback and internal rate of return. To a lesser extent, we found companies were using net present value or life cycle costing. So I think there are a lot of ways that companies could actually implement their action plans. And I think it's something, if we do this kind of activity again, to explore more.
Yeah, I will just put a plug in for, there is an industrial partner meeting coming up in, do you remember? I think it's in September, if I remember correctly.
It's November this year.
November. Okay,
Yeah,
sorry. Anyway, yeah, but that is a good opportunity for people who are in Energy Star partners or want to join the partnership, because there is a lot of that kind of informal discussion that's very helpful at those meetings to learn more.
Yeah, exactly. My email's in the slide, so email me if anyone would like more information on that.
Yeah, very good. Okay, one more for you, Danny. When you did the questionnaire, what would you say was your biggest surprise? What was the most unexpected finding?
That's a great question. I alluded to this a little bit in the presentation. I wouldn't say I was surprised, but I was really excited to see this. I was really looking at the goals and how many companies had both an energy goal and a greenhouse gas goal. Within the last few years, especially, there have been conversations. Companies are transitioning from energy to greenhouse gas. Others are staying with energy. Some are doing both. So I was really interested to see that other companies that participated, 2/3 have both, and about half have greenhouse gas energy and renewable energy. And I think it'd be great to have a moderated discussion with companies just to understand a little bit more about the rationale and how they selected them.
Yeah, it is interesting. I find that sometimes people get confused and think energy efficiency and greenhouse gas reductions are the same. And of course, there's overlap, but they're not the same. So in my mind, there's an educational component to that as well.
Yeah, they're all metrics, and just like whenever you're evaluating a project, you're going to have different metrics for that. When you want to evaluate energy sustainability, you want to have different metrics. So energy and greenhouse gas.
Yeah. Okay, back to Amy and Andrea. So there was some discussion in your presentation about behavioral changes, and I think that's a great thing to do. It's a no-cost thing. It gets people engaged. But the thing I always worry about behavioral changes is trying to maintain those. So I just wonder if you could speak to what you think the biggest impact you can get with behavioral changes is, and any tips for maintaining those.
Yeah, I'll just quickly say that what we usually do is identify. We'll do in normal times we'll do a physical walkthrough of a facility, and obviously you can often see things. I like to use an example about putting sensors on the pop machine so that the light isn't always on unless you're walking by, like at the some of the grocery stores. Practical things like that won't impact anything, but they're small ways that add up to save energy. And so we use those opportunities that get listed in the report from a facility assessment to go back to customers and get those verified and things like that. So that's more the how, but I'd be interested in Andrea's perspective, since she's in more facilities ongoing, and what you think, Andrea.
There's definitely an educational component to that, and convincing folks that, implementing these operational measures really do make a difference. And certainly having them documented so that you can see on paper, this is how much energy you're spending by leaving this machine running, for example. And, this is how much energy is being wasted, essentially, what's the dollar amount you could be saving. And when you really add up several operational measures together, it can be a meaningful chunk. And so facility assessments with the reports really do help put that on paper, which your point of contact could then share with their leadership team, and then energy management programs that really provide that ongoing coaching to really instill an EE mindset into folks. I think that's really important. It's really just convincing people to get on board, and they can pull in other members of their team and kind of teach them along the way.
Okay. One other question for you, Carlos. So I'm really interested in the microgrid, and wondered if you could comment on how you anticipate battery storage could integrate with the microgrid.
Battery storage is a very useful technology, especially for increasing the amount of renewable energy that can be used on site, and also for providing resilience for short periods of time. So it's a really, really interesting technology for those two features. It's unlikely that battery storage will hold an industrial company working for many hours, but it's very useful for power fluctuations, for these transition periods between grid connected and when the microgrid is connecting and disconnecting from the grid. So it's a technology that has quite a bit of future, as we all know. So I'm not saying anything new.
Okay, thank you. That covers all the questions from the audience, but we do have a few more minutes. So let me just ask, do any of you have any questions for each other, or just any final comments you'd like to make? Any final words of wisdom?
No, it's just been a pleasure. Thanks for having us.
Okay. All right, anyone else?
Thanks for the opportunity to speak today.
Okay, well, we definitely appreciate everyone's participation. I'm sorry, Danny, were you about to say something?
Yeah, just wanted to echo the same comments. I enjoyed everyone else's presentations, learned a lot over the last few days, and hope it was as inspirational for you as it was for me.
Yeah, same here. Thank you for the opportunity, and feel free to reach out if we can help with anything, we will.
Very good. Okay, well, thank you all. I certainly appreciate your participation, and I agree with Danny's comments. It has been inspirational. I always find it uplifting to meet with other energy managers and people working in energy efficiency, and so it's even remotely, it's been really nice to get to do that this week. So thank you.
Thank you.
Thank you very much.
Thank you.